All right. Monochromatic light falls on two very narrow slits 0.045 millimeters apart. Successive fringes on a screen 6 meters away are 7.2 centimeters. Well, golly, that looks like a small angle. I want to use this formula. Okay, so let's do that. So determine the wavelength and the frequency of the light. Okay, we can do this. The S is lambda d over the slit separation. So d, this is d right here, right? This is 6.00 meters. This distance here, this is not to scale. This distance from the center of that slit to the center of that slit is 0.045 millimeters. Right, and then our wavelength of light is what we're trying to find, right? So we're trying to solve for a lambda, right? So this, we have 0.072 is our distance, right? That's 7.2 centimeters, right? Divide by 100 is equal to lambda times 6 over the slit separation, which is 0.045 times 10 to the minus third. All right, I can do this. So 0.072 times 0.045 e minus 3 divided by 6 should give me my wavelength. And the wavelength is 5.40 times 10 to the minus 7th meters, which is 540 nanometers, by the way. Okay. And then what is the frequency of the light? The frequency of the light, we're just going to use this. V is f lambda. The speed of light is 3.00 10 to the 8th. It's actually 2.99 something that rounds up, right? Is the frequency times 540 times 10 to the minus 9th. It's going to be a big number here. All right, here we go. So 3E8 divided by the answer I just got is 5.5, a lot of fives, let's say 5.56 times 10 to the 14th hertz, okay? Or 5.56 boogala hertz. Sorry, I can't help myself.